Hi everybody, this is Brandon Tolbert from TopDogEngineer.com. Today we're going to talk about, you guessed it, structural engineering and free body diagrams. Yeah, free body diagrams. If you want to be a good structural engineer, you got to start with the free body diagrams. You can't do that simulation junk until you get good at this, man. This is just where it's at. If you're an up and coming engineer or if you want to be a structural engineer. So we're going to talk about that today. And it makes me excited, to be honest with you, because that's where it's at. If you can draw it on paper, do the back of the napkin calculation, you know what? You just have an upper hand over everybody else. So we're going to talk about that today. So let's get started. Hey guys, welcome. I'm going to step through this problem because it's a good fundamental problem that I think if you understand the methodology to solve this, although it may not be the exact problem you're facing, you can definitely extend these steps to solve other similar problems. So as a structural engineer, what we like to do is we do computer simulation, but we have to be able to back up those results with a hand calculation. A lot of times your supervisor will come to you and say, hey, verify these results. And the only way to do that is with the stuff you learned in school and by looking at things in 2 dimensions. If we look at things in 2 dimensions, we can solve lots of problems with what we learned in statics and solid mechanics, etc. And so if you're not able to do this, you need to take a step back and reconsider if you want to be a structural engineer. Because if you can't do it, you're not really cut out to be one. But that shouldn't really worry you because this stuff is pretty simple. And I'm going to try to break this down as easily as I can and also keep it within the time constraints that are reasonable. So we'll kind of go through this kind of fast. But anyways, let's go ahead and get started. So what you have here is you have an assembly with multiple members on it. And as we step through this problem, I want you to think about these key concepts. I want you to think about 2 force members, the geometry of 2 force members, and we'll go into detail on what these are in the upcoming slides. But also free body diagrams, being able to break things down and draw the reaction forces on each member. And also determinant structures. So a determinant structure is basically a structure that you can apply the equations of equilibrium and solve the problem. And so we're not going to get into equations of compatibility. That's just a little bit out of the scope of this video. And also I want you to think about equal and opposite forces. So as you begin to replace these nodes with forces, if you break this assembly down, they're going to exhibit equal and opposite forces between members. So just keep that in the back of your mind. So let's get started. So the methodology you want to start with is you want to identify the 2 force members. What are 2 force members? 2 force members are basically those members where there's only 2 locations where forces act. So if you look at this assembly, I want you to think about which of these members, and there's basically more than a few here, which are going to be the ones that are 2 force members. So if you want to pause the video and think about it, go right ahead. I'm going to go ahead and show you what they are. So the 2 force members in this assembly is going to be this member here and this member here. And as you can see, there's only 2 points on this member where a force would react if you took it off the assembly and had to replace it with reaction forces. These other members, so this member right here, you have 1, 2, 3, 4 reaction forces acting on it at least. And then right here you have 1, 2, 3 on this member, so that wouldn't be a 2 force member. So why do we want to identify 2 force members? Well, they greatly simplify the free body diagram. What may be an unsolvable problem on the surface can be solvable if you break it down into 2 force members. And that's really the point, is to simplify the free body diagram. And you can see here I broke these 2 members out and replaced the reaction forces, and those reaction forces are going to be equal and opposite on these members. And so the advantage of that is you only need 2 equations of equilibrium to solve for these, and also you need to know the geometry. So that's really the focus. Break it down into 2 force members. Do that first. The next step you want to do is you want to draw the free body diagram of each component. So you basically take an exploded view of each of these components and you replace the areas where you move them with reaction forces. And you can see here, I removed this member from this member, so the forces are going to be equal and opposite here. They're going to be the same because they're touching at the same location. And so the goal here is to basically take a step back and say, okay, I need to identify a body where I can solve for reaction force, and then I can translate these reaction forces down the line and solve for the others. So what you really have is you have three equilibrium equations in your pocket: a moment balance, and a force balance in the x direction, and a force balance in the y direction. So what you're looking at in these members, you're trying to find the member that's got a minimum or a maximum of three unknowns. And so you can look here, we have two unknowns here, but we don't have a force value to relate it to, so we can't solve for this. The same here, and this has too many reaction forces. There's 1, 2, 3, 4, 5, 6. I can't solve that. I only have three equations. I have to have three equations and three unknowns. And so if you look here at member 5, check it out. We have three unknowns: a tension load and two reaction forces at the middle, and then a force to relate it to. So essentially body 5 is the one you want to start with, and that's really the only one in this problem you can start with, because all these others you can't solve. But if we start with body 5, we can begin the process of determining the reaction forces on each member. So the next step you want to do is you want to take body 5 and you want to solve for the external forces on that body using your three equations of equilibrium. And so as you can see here to the left, we have 1, 2, 3 unknowns, and we have a force. And so we can solve this problem. And I've shown the math over here to the side, and I don't really want you guys to focus on that. I just want you to focus on the process. But if you're interested and you want to work through the hand calculations, feel free to do so. Practice makes perfect. And this is, I have the answers right here, and you can definitely do it if you're ambitious. And so you can see we can solve for the three unknowns and we get an answer. Now what we do is we translate these forces down the line into these other members. And if we do that, we end up with a solvable problem on body 3. Body 3, see here? We translated those external forces right here. And now, check it out. We have three unknowns. And two reaction forces here and one reaction load here. And so, guess what? Three equations, three unknowns. Whoop-de-doo. We can solve this. Bam! Check it out. And so, I've gone through and solved it here. And my apologies there, but here it is. We get answers, and so we translate these forces down the line, and we do the exact same thing. And now check this out. We have a two-force member. Recall that a two-force member, we have equal and opposite forces acting on these members. Well, guess what? All we do is we have our answer right there. Our reaction load is going to be equivalent to this in the opposite direction. And if you notice here, I got a negative value. What does that tell us? The negative value tells us that we need to flip the vector. So if we flip the vector, we can change the sign, and in reality, this member is in compression rather than tension. And so that's all we would do. And I like to go ahead and just solve the problem all out, and then I flip those vectors at the end for the negative values. And that just keeps everything consistent, and I don't really have to worry about my math when I keep everything the same at the moment. So we'll change that at the end, and I'll show you how that works. But then we just translate the forces. I mean, this is repetitive, guys. This is the same methodology. I mean, we translate the forces we solved to the nodes, and we end up with three equations. We have three equations in our pocket, and we have three unknowns.
right here and 2 reaction loads down here. And here's the math. Bang. You just crank it out, guys. It's like clockwork. I mean, it is not that complicated. So just keep working through it. And the last one's a 2 force member, and we know how to solve those. And so the reaction load will be equal to 500 here. And so, guys, I mean, that is essentially it. We've gone through and solved for the external forces or the reaction forces on each member. And we've completed the problem just by breaking it down into simple steps. And so here's our answer right here. So what I've done here is I've shown the reaction forces on each of these members that we calculated in the previous slides. And feel free to pause the video and go back and verify these results. I think it's a great exercise for anybody to do. And if you're really motivated and you want to get good at this stuff. So in red are the forces that were negative. And so I basically flipped the force vector there. And that's the last step, is to flip the direction of the negative force vectors. And so as you can see here, I just flipped them and crossed out where they were pointing originally. And we can change those values to positive numbers. And so, guys, that is it, man. You guys are going to become free body diagram phenoms by the end of this if you work through this and understand this. So I broke it down into 4 steps. That's really, the math is the math. You may make mistakes with math, but I'm telling you, if you understand the methodology, I mean, you'll just begin to see the parallels and see how all these problems are relatable. And so that's the main focus of this presentation and what I wanted you guys to get out of it. So the steps we went through are to identify the 2 force members. Why? Because this greatly simplifies the free body diagram. And then you needed to break down each of the assembly components into free bodies. And so we did that, and we replaced the forces or the reactions with force loads. And then the next step is you want to identify which component is solvable. So you got to have the same number of equations as the number of unknowns to solve the problem. And you have 3 equations of equilibrium in your pocket. So you really just need to find those components that you know you can solve for, and just translate the forces down the line, and you can solve the problem. And then the last step is to flip the direction of the negative force vectors. And you're done, guys. You are you are qualified to move on. But what I want to reiterate here is that you can solve this one problem and do it right, but you need to do multiple problems. You need to open up a textbook and just work through problems, guys, and just draw the parallels until it gets easy. I mean, guys, what you put in is what you get out, and that's just how it always is, and there's really no shortcuts. If you think there's a shortcut, that's a myth, guys. You need to put in the work, and believe me, just understand. Focus on understanding, and you'll be glad you did later down the line, because you'll retain it, and you'll be able to apply it to more complicated problems, and you'll be able to impress your colleagues and make a contribution. So, guys, that's it. I hope this was easy. I hope you understood this, and there's more to come. Y'all have a good day. Adios.
Boom! There we have it, guys. You're on your way to becoming a structural engineering phenom, like your mom and dad always wanted to be, right? No, not really. But you're getting better, and this is the foundation, free body diagrams. And every time I do one, I get fired up because that stuff's just exciting. And it's something you can do back of the napkin calculation that just can alleviate a lot of concerns about your structural analysis problem and confirm your results from computer simulation. So, guys, continue to get better at this if you're interested in it, and put in the work, put in the time. I can't stress that enough. The amount of work you put in is the amount you get out. That's always been the case in my life as an engineer, and you're always going to face different problems, but you can always go back to your foundation if you develop the skills and apply those to more complicated problems. That's always been the case. You know, don't let anybody tell you otherwise. You know, it's all the same. It's all energy balances, force balances. Just, you know, if anybody tells you different, then, you know, they're not an engineer, I guess. But yeah, it was good to have you guys listen in, and I want to give you guys a high five. I wish I could, but definitely pat yourself on the back and continue to work and get better. And like I said, if you have any questions, if you have any concerns or anything, just always, you know, this Nike symbol does justice. Just do it. Don't get caught up in all the noise. Just do it. Okay? Put in the work, put in the time, trust your instincts, make it happen. So, more's to come, guys. This is my first video in a long time, but I want to do more of this. So, you guys stay tuned and rest up